Hello students, welcome you all on my channel. This is the last video related to the chapter excretory system, and in this video I'm going to focus on urine formation, which is related to physiology of excretion. I have had already discussed the physiology of excretion. The first part, that is the ornithine cycle, you may see in my video, that is related to the excretory system. In this video, I'm going to focus on urine formation and how the urine formation is taking place in the uriniferous tubules, that is to say in the nephrons. As you are familiar that nephrons are a structural and functional unit of kidneys. So here, urine formation taking place in the uriniferous tubules. So always remember, the urine formation taking place in uriniferous tubules, that is to say simply nephrons. It requires three stages. The first one is ultrafiltration. The second one is tubular reabsorption. And the third one is tubular secretion. These all events taking place in the uriniferous tubules. Always remember, the urine formation is the final process of excretion. Here, the unwanted materials are eliminated from the blood and the useful constituent are returning into the bloodstream for further activity. So, must remember this. This is a stage. Urine formation stage include three sub-stages: ultrafiltration, and this ultrafiltration taking place in the Malpighian corpuscles. As I told you earlier, that Malpighian corpuscles is combination of Bowman's capsule and glomerulus. So here, in ultrafiltration, the filtration of blood is taking place under high pressure. So in ultrafiltration, filtration of blood takes place at high pressure, in the Malpighian corpuscle, Now here, see, the one important point is the efferent arteriole is very narrower than the afferent arteriole, and they collectively forming a chain in the Bowman's capsule, and due to the high pressure of blood in the Bowman's capsule, means in the ultrafiltration process, due to the high pressure, hydrostatic pressure is created, and that results into direct movement of large amount of water, drugs, all type of amino acids, glucose, uric acid, urea, etc. into the Bowman's capsule, this is structure. So as I'm telling you, one must be afferent arteriole, and other must be efferent arteriole. Efferent. So I told you the efferent arteriole is much thinner as compared to afferent arteriole, and they are coming close together in the Bowman's capsule and forming a network of capillaries called glomerulus filter. And here the unwanted material that I told you, water, all amino acid, glucose, uric acid, salts, they are accumulated into the Bowman's capsule, this one. And now the next process will be tubular reabsorption and tubular secretion. Tubular reabsorption and tubular secretion. So first I want to mark some points here so that it will be easy to understand. The first point in the tubular secretion is that filtration of blood is taking place under high pressure. Blood filtration takes place at high pressure. The second point is that the efferent arteriole is thinner than or narrower than afferent arteriole. Which create a hydrostatic pressure. Hydrostatic pressure is created in the Bowman's capsule. Which leads to filtration of blood. As I told you, the unwanted materials, means excess water, is just passed from the glomerulus filtrate into the Bowman's capsule for elimination. Not for elimination, there are certain other materials that will be beneficial, that will be reabsorbed, that the reabsorption will take place in the next step. This is the first step. And one more vital point that I am going to mention here, that ultrafiltration is not possible without the combination of glomerulus filter and Bowman's capsule. So both glomerulus and Bowman's capsule participates in ultrafiltration. So this is the key points related to the ultrafiltration. And I'm going for the next point, that is the tubular secretion. So please, you may note down. The second point is the tubular reabsorption. See students, in this heading, tubular reabsorption, the useful constituent, that is to say the materials, are reabsorbed by the tubules. Tubules here, tubules are the PCT, loop of Henle, and DCT. So don't get confused. Tubular secretion means only the DCT or PCT is taking part here, the both. So in tubular secretion PCT means proximal convoluted tubule, DCT and loop of Henle participates. Thus, the next point is that the useful materials that may be water, maybe salts, maybe cation, maybe anions, that will be absorbed by the process here. Two processes are here in tubular reabsorption. Always remember, reabsorption means useful materials are reabsorbed and sent back into the bloodstream for its further use. Here the useful material are sent back into the blood for its other use. Now in this, the both process, active and passive transportation takes place. In active transport, the certain cation like chromium, potassium, sodium, amino acids, glucose, certain useful drugs. Mostly the drugs are eliminated, but here there are certain drugs, vitamins, hormones, etc. are reabsorbed, or you may say that absorbed. In the passive process, water, chloride and other anions and other are reabsorbed. See, it has the processes. Now the PCT participate in reabsorption, and it reabsorbs roughly 75% water, amino acids, the selected material are amino acids, 75% of water, amino acid, glucose, salts, etc. Now in PCT it is complete. Now in DCT, tubular secretion takes place. Tubular secretion, I'm writing here, tubular secretion takes place. which I will discuss in the separate heading of the tubular secretion. Now, one more point is there, that is a loop of Henle. Loop of Henle. Loop of Henle. Act as a counter current. Act as a counter current and reabsorbs water in the case of water deficiency. So here, act as counter current, and in the case of water it reabsorbs water. Actually, the ascending part of the loop of Henle is impermeable to water, but the descending part of the loop of Henle is permeable to water. If the body is facing a water problem, means there is deficiency of water, then this participate in counter current mechanism, and this aids in hypertonicity of the urine. So it maintains concentration of urine. Now student, you may just copy it down. So I'm going to erase this. Now the last sub-stage of urine formation is the tubular secretion. The third one is tubular secretion. In this process, all the unwanted material are eliminated from the body in the form of toxic nitrogenous material, and that will be dissolved in urine. So in tubular secretion, undesirable materials, means nitrogenous wastes, and nitrogenous waste materials such as urea, hippuric acid, creatinine, uric acid, that this is the urea, hippuric acid, creatinine, uric acid, and other toxic materials. Always remember one point, that tubular secretion takes place by active process. Tubular secretion takes place by active process. In tubular secretion, elimination of H ion, K ion, and certain drugs takes place. The drugs may be the immune suppressive drugs like methotrexate, cyclosporine, or the high dose antibiotics. Maybe related to the first generation or second generation or third generation. So this is all about the tubular secretion. Now I'm going to focus on the main part of the excretory system, that is the last part, and this is the diseases of the kidney. This is the diseases of the kidney. So please note down. Diseases of the kidney. There are many diseases like polyuria, nephritis, glycosuria, alkaputnuria. There are a lot of diseases, kidney caniculi. There are many diseases, hematuria, that will be discussed under the heading of the kidney diseases. Kidney, about a disease called hematuria. Hematuria. Hem means the pigment. When the person urine contain RBC, obviously if the RBC will be present, then obviously the color of urine would be red, and this is because of the disorder called hematuria. Means presence of, you can say like this, presence of RBCs in the urine. The second one is pyuria. Means here it is related to pus in urea. Pus in urination. It is very fatal. This is the infection. This is the acute infection in the kidney, and if untreated, it will be chronic. The third one is a renal caniculi. It is called kidney stones. Kidney stones because of high dose of calcium or a uric acid in the blood. The fourth one is alkaputnuria. It is due to the presence of alkapaton. It is due to presence of alkapaton due to presence of homogenistic acid. The fifth one is most common hematuria, that is the glycosuria. Means when the person will excrete glucose in his or her urine, then the disorder give rise to glycosuria. Glycosuria means high concentration of glucose is eliminated via urine. So a high concentration of glucose is excreted through urine. The sixth disorder is anuria. Anuria means absence of urination, means a person will fail to urinate. Anuria, A-N-U-R-I, anuria means absence of urination. So there are a lot more disorder related to the kidney. This is the main vital one. And one more vital disorder that is very common, renal failure. In this disorder, individual kidney or both kidney fails to both the kidney or individual kidney fails to excrete harmful toxic substance, that is to say nitrogenous waste material. Kidney fails to excrete nitrogenous waste material, and if untreated, death occur due to the deposition of nitrogenous waste material in the bloodstream. So it's all about the chapter excretory system, and this excretory system is completed. Now in my next video I will start the nervous system, so student stay tuned with the channel and feel free to comment and ask any question if you have doubt, and feel free to subscribe my channel. Thank you very much.